In the previous episode, we installed an AMR500 supercharger on our 719cc Kubota diesel engine. Actually, we installed it on our spare diesel engine first, that way we could design all the parts to make the supercharger fit in the limited space under the hood of our project car. Once we solved all the fitment issues, well, it was time to install the supercharger on the actual car. The good news is everything fit perfectly, and trust me, that was no easy task. Anyway, we fired up the engine and discovered the supercharger was developing 6 psi of boost at idle, and off idle it easily made 10 psi. Although we didn't try, we figure at full throttle there was a good chance the supercharger would make 12 to 14 psi, possibly more. Now, overall, this is very good news. However, our goal was to initially limit the boost to around 8 to 10 psi at full throttle. So it was back to the drawing board to do some more engineering. Tuning a positive displacement supercharger to develop the desired amount of boost can be a bit tricky, especially on a tight budget. And when I say tight budget, I mean cheap. You know, doing incredible projects as inexpensively as possible is one of our specialties. Anyway, I asked our team of experts what the next step should be, and a lot of you folks thought the most cost-effective solution to reduce the boost was to change the pulley sizes. Bingo! I'm forever grateful for having such an intelligent audience. Oh yeah, there are dozens of ways we could do it, but let's try to keep it simple and cheap. So the first thing is to figure out what our actual drive ratio is with the current setup. And long story short, we have a 0.707 to 1 overdrive, or in other words, this pulley spins 1.4 revolutions every time the engine spins once. So in order to reduce the boost, we need to slow down the supercharger a little bit. And while we're at it, we're going to be making some other changes. So one of the changes we're going to make is, well, it's not really a change at all. Now, before we added the supercharger to the engine, the drive belt for the alternator and water pump was like this. However, when we added the supercharger, we increased the length of the belt so we could drive everything with a single belt. Now, the single belt theory turns out to be problematic when it comes to modifying the drive system in the future. So we're going to go back to the original setup to drive the water pump and the alternator. And what that means is we're going to use a second belt to drive the supercharger. Of course, that creates a whole set of new problems, but in the end it makes modifying the system in the future much, much simpler. Now, if you watched the previous video, you may remember that when this engine's in the car, there isn't a lot of space for all the junk that we want to install. And if you didn't watch the previous video, well, there ain't a lot of space for all the junk we want to install. So somehow we have to squeeze a second pulley onto the crankshaft in order to drive the supercharger. And that might be a challenge. And here are the pulleys we're going to use. As I recall, these are power steering drive pulleys from a Volkswagen Golf. So now we have Volkswagen parts in this Honda with a diesel engine from a refrigerator coupled to a Gen 1 Saturn MP3 transmission. Of course, let's not forget the superchargers from a Subaru Rex. Meh, parts is parts. Anyway, these skinny pulleys will slow down the supercharger by providing a 1-to-1 ratio, and with a little ingenuity, we can actually get them to fit in the limited space. So it looks like in order to get the crank pulley to fit, we're going to have to cut a little bit of metal from this cross brace, and I don't see a problem with that. Now, to get the other pulley to fit the supercharger, well, according to future Jimbo, it's difficult, and you'll see why as this video progresses. So let's do the easy part first and get this pulley to fit the crankshaft. I reckon we need to take this bolt out to see what's going on. Now, I did find a washer that fits perfectly inside the center of this pulley, and it's the exact size of the crank bolt. You know, I guess we could just weld the washer to the pulley and skim the weld off on the lathe, but that's borderline sketchy, especially the way I weld. So we're going to use this steel backer plate behind the pulley. Now, this backer plate by itself doesn't do much, so we'll have to shoot a couple or 3 welds in these holes to hold it all together. You'll see, it'll be fine. Off camera, I prepped the pulley for welding, as you can see by the lack of paint. Anyway, I wanted to make sure that the backer plate is centered to the pulley, so I also machined a fixture that'll hold everything together perfectly centered during the welding process. At some point, we'll have to drill out the center of this backing plate to fit the crank bolt, but for now I want to try to maintain a good center. Now, before we weld these parts together, I went ahead and drilled the backer plate to give the weld sufficient penetration. This will guarantee that the finished pulley will be a solid and reliable part. My welding equipment is actually made for auto body repair, and a lot of times I like to preheat my parts because, well, the welder doesn't have a lot of horsepower, if you know what I mean. After preheating the parts, it was time to zap them with the MIG welder. Now, these welds are going to get in the way of the crank bolt flange, so the next step was to skim the welds down on the lathe. There's plenty of penetration on the welds, so this isn't too sketchy. Now all we have to do is open up the hole in the center to allow the crank bolt to fit. So now that we have a usable crank pulley, we have to come up with a way to lock these two parts together. And I figure we can just pin them together. Now before I mark the crank pulley, I want to point out that this mark that's already on the pulley is a factory mark, and it's there so the pulley can be installed correctly on the engine to maintain balance. To drill a hole for the pin that will lock these pulleys together is difficult as far as alignment goes. So off camera I 3D printed an alignment fixture that'll allow us to center punch the crank pulley, and the same fixture also fits the supercharger drive pulley. So using this fixture, we can guarantee the holes will line up on the parts once we're done drilling them. And over on this pulley, you can see how the fixture fits the center hole for a perfect alignment. The center punch I'm using is custom made for fine point marking. Basically, I harvested this rod from an old CD-ROM drive and put a point on it. The rod is super hard and it can keep a precision point for a long time. So if you have any junk CD-ROM drives around, you can make one of these awesome center punches for free. And now we drill. Off camera I installed this roll pin in the crank pulley, and this should be enough to prevent any slippage between the crank and the supercharger drive pulley when the engine's running. Let's see how it fits. Not too shabby. And now let's see how it fits on the engine. Here's something to keep in mind if you're following along. Due to the camera or the angles or whatever, this engine appears a lot bigger than it really is. So in reality, we're working on tiny parts on a tiny engine, and all the stuff we're doing is more than adequate for this application. I know it's easy to lose track of the scale of this project because this thing actually looks a lot bigger on camera. Let's deal with the supercharger pulley next. So the pulley that came with the supercharger is made of cast iron, and that kind of makes things more difficult. Now, when I place the new pulley over the cast iron pulley, none of the existing holes in the new pulley will line up with any solid material on the cast iron pulley except for the inner hub. So I reckon we'll bolt these two together with a spacer between them. It will make more sense in a few minutes. In order to keep everything centered, I 3D printed another alignment fixture, and this gizmo fits the new pulley perfectly, and it fits the backside of the cast iron pulley perfectly. So this fixture will allow us to transfer the hole locations on the new pulley to the cast iron pulley and keep everything centered. With the cast iron pulley marked for the new holes, it was off to the mill to drill and tap them. Cast iron is always a pleasure to drill and machine. It's like cutting butter. And there we go. One of the 3 holes drilled and tapped. I'll do the other 2 off camera. Okay, now that we have the cast iron pulley drilled to match the holes in the new pulley, we need a spacer to fill in all the gaps. And off camera, that's exactly what I built. This thing took about 3 hours to make, well, because it's a complex, one-of-a-kind part, and of course it's built without any drawings. Yeah, it fits pretty good. Now, like I said, I didn't use any drawings. However, I did use a 3D printed fixture to mark all the holes. Yeah, it's cheating, I guess, but I'm making the best use of all the tools I have. So now we have all the parts we need to put the supercharger back on the engine. This is the cross brace for the motor mount, and it's already been modified for the extra clearance. That of course reduces its strength, but this brace is made from 3/16 thick steel, so I think it'll be okay. Now this guy over here is something I made off camera, and we may or may not need it. It's for adding tension to the drive belt. We'll get back to this later. Yep, the welds ain't that great, but it'll work. Let's assemble all this stuff on the spare engine so you folks can get a better look. So this belt tensioner is something that may or may not be needed. It's hard to say. The belt tension seems fine without it, but we have the space for it, and why not use it for now? Okay, well, soak it in, because when this stuff is installed on the engine that's in the car, you won't be able to see much of it. Alright, time's up, and through the magic of editing, in the next scene all this junk will be installed on the car. And it's in. I'm getting pretty good at installing this stuff. I think this is the third or fourth time I've done this. Everything went well until I tried installing the modified Kubota crank pulley. You see, that's when I discovered the crank pulley that was already on the engine is about a ½ inch bigger. Meh, bigger, smaller, it makes no difference as far as parts go. The problem is I based my math for the ratio correction on this smaller crank pulley. So what that means is, we thought the overdrive ratio was 0.707 to 1 on the previous setup, but it was actually quite a bit more. The bottom line is we may have overcompensated with our new pulley setup and reduced the boost too much. Well, there's only one way to find out. So far, so good. No wobbles on the crank pulley, and the supercharger pulley looks good. That's a relief. Let's check that boost. Well, maybe 2 pounds at idle, and that's pretty good. I'll take it. Let's see what happens if I give the engine some revs. Oh boy, off idle we're only getting 4 pounds of boost. We may get another pound or two at full throttle. It's not the greatest, but it's good enough for today. Looks like we have some rain coming in. I reckon we still have enough time to take the car out for a road test. I'm curious to see if the lower than expected boost will make a difference. Well, I apologize for the scratchy audio. I'm going to turn down the volume for the road camera. That's better. Now, it's been a while since I've driven this car. You know, it doesn't feel slow, but it also doesn't feel fast. It actually feels, okay. Possibly a little faster. I don't know, it's hard to tell. Now, if you're new to this channel, the little 719cc diesel engine that powers this car only makes 20 horsepower from the factory. Last year, we installed this very same engine in a stripped-down Saturn coupe, and we installed a turbocharger. Well, the turbo's gone, but the fuel rack is still set up for the extra fuel the turbo needed when it was developing boost. So we have that going for us. Is it going to be enough fuel? Well, that's the question. This little bridge that's coming up was closed for about a week so they could fix the bumps. Meh, I don't want to sound like a jerk, but it seems like they made it worse. At least they tried. Now, according to the boost gauge, we're making a solid 5 pounds of boost. That's about 3 pounds short of our goal, but it's a good starting point. Longtime viewers know that our project cars actually run and drive for more than one episode. Generally, we make about a dozen or so videos as we make improvements, then we move on to something else. My point is, yeah, we could throw 20 pounds of boost at this engine and it may survive for a day or a week, and then you would never see the car again because the engine would be blowed up. Instead of doing that, we like to build on performance and gather data along the way. A lot of what makes this car possible is all the hard work we did on the Saturn last year, and we're still using the same engine. So at cruising speed, the exhaust gas temperatures appear to be slightly lower than normal, and that's good to know. How fast is it? Well, let's find out. We're not going to be using the draggy today, so we'll do it old school. The time to beat is 35.19 seconds for the 0 to 55. Okay, well that was not expected. We got to 55 miles per hour in only 23 seconds. That's a difference of 12.23 seconds. I reckon the Supercharger works. You know, one of the performance issues we were trying to resolve was the lack of power when shifting at full throttle. And I have to say we are definitely on the right track because, well, the numbers speak for themselves. Anyway, this is very interesting, and I think we need to do a full performance review, including fuel economy, in the next video. So the AMR500 Supercharger turned our 719cc diesel-powered, goofy-looking Honda Insight into a real contender. Now, keep in mind, this ain't a Dodge Demon Hellcat Red-Eye fast. It's more like lawnmower fast. You've seen the numbers. We ain't gonna impress the chicks with this rig, that's for sure. Now, what's nice about the Supercharger is the instantaneous boost, and as it speeds up, the compressor seems to be slightly more efficient. Unfortunately, we were only making a mere 5 pounds of boost today, but that seemed to be enough to make a difference. So if you recall, at the end of the acceleration test, we tripped the exhaust gas temperature alarm. So what that is telling us is the fuel rack setting is providing more than enough fuel at full throttle. Remember, on a diesel, more fuel equals hotter exhaust, and in our case, the engine really wants more boost for the fuel settings that we have. This is all very interesting. Now, here's another data point that some of you may not have picked up on. At cruising speed, the exhaust gas temperatures were slightly lower than normal. So, generally on a diesel, the lower the EGT, the better the fuel economy, which is great. However, we also have to consider the energy that the Supercharger is absorbing from the engine. So I'm curious to see if this setup helps or hurts fuel economy. If I had to guess, I would say it's not helping at all. And to me, that's obvious, but I could be wrong. So just for fun, we need to find out. So many questions and not enough time today. If you're interested in knowing how this project develops, well, consider subscribing if you haven't done so already. You know, if weird automotive experiments are your thing, we have over 100 videos on this channel where we fool around with tiny engines in our effort to go faster. Yeah, I know an LS would solve all our problems, but you can't drive an LS at wide open throttle on public roads for more than a few seconds. On our cars, wide open throttle is the name of the game. Anyway, I had fun today and I hope you did as well. And before you know it, we'll be back with answers for questions you never asked. Until then.